So having a look at this series on the board, you can see that we have a plus a times r plus ar squared, so on until a times r to the power of n minus 1. So just having a look at that, it should remind you of a geometric series, doesn't it? And that's because you can see that each term is being multiplied by r. Can you see that? So what we've done here is we've just factorised out a, the first term, because you can see it's common for all of it. So we've factorised that out, and that's something that we're going to do in most of our time payment questions, so just become familiar with that. And we're left with this geometric series here, which looks very familiar to you. Now, a very important point that I want to make to you is that you can see, although our final index says n minus 1, altogether there's n terms. Now, why is that? That says n minus 1, so why isn't there n minus 1 terms? Well, the reason is because of our first term here. You can see that our first term is a, but what we should actually consider it as is a times r to the power of 0. So this is r to the power of 1. So we're actually going from 0, 1, 2, 3, etc. until n minus 1. So this term here gives us a plus 1, which makes it n terms. So what I mean by that is, let's just imagine that this is ar to the power of 6. So we're not going from 1 to 6, which would give us 6 terms. We're going from 0 to 6. And that's why we would say there's 7 terms. There's one more term than what this index is. So what you see here with the 1, I want you to consider that as r to the power of 0. And then you won't forget that although this is n minus 1, there's actually altogether n terms. So now we found out that the first term in this case is just going to be 1, because we factorised out a. Now r, which is just our ratio, and n, remember, that's our number of terms, which here we've just worked out to be n. So that's a number of terms. Now this is, what's this? Good, it should be the sum of the geometric series, isn't it? So this is just the equation that we sub this into. So we just have our first term a multiplied by the ratio, which in this case is just r, to the power of number of terms, which is n in this case, minus 1, over r minus 1. Now this is the equation that I want you to just commit to memory and know off by heart. So you should know a, the first term, times ratio to power of number of terms, minus 1 over r minus 1. Now, some of your textbooks may write this as 1 minus r to the power of n over 1 minus r. It doesn't matter, it's still the same. So just remember what you're most familiar with. Okay, so I really want you to remember this equation, as well as the fact that even though it's n minus 1 here, there's n number of terms because there's an r to the power of 0 there. Alright, let's work through some questions now which uses this equation so we become more familiar with it. In question 1, we have this series here, and we want to find the sum of this series, and we're going to correct to 2 decimal places. And why we're doing that is because in time payments we'll be working with money, and money in what we're used to is always going to be to 2 decimal places. Okay, so looking at the series on the board, we have 1 plus 1.05 plus 1.05 squared, so on, until 1.05 to the power of 6. Now, what the first step I want you to do is find out a, what's the first term? Well, that's quite simple in this case. It's just going to be 1, isn't it? Now, what do you think our ratio is going to be? Good, exactly. It's going to be 1.05 because you can see that each term is being multiplied by 1.05. Now, what is the number of terms going to be? So remember, even though it's to the power of 6, because essentially we have 1.05 to the power of 0 here, altogether, if we count, there's going to be 7 terms. So there's actually n equals to 7. So now that we have what a equals to, what r and n equals to, we just need to substitute it into the equation, which we remember as this. So substituting it in, we have 1 times 1.05 to the power of 7, our number of terms, minus 1 over 1.05 minus 1. Now all you need to do is just put that into your calculator and round to 2 decimal places, which should give you 8.14. So what we've done here is we've just worked out what a, what r, and also what n equals to, and just substituted into this equation. And I think the most difficult part here is remembering that although this is 6, there's going to be 7 terms. Okay, let's have a look at the next question. So in question 2, we want to find the sum of this series here. So we have 100 plus 100 times 1.1, so on until 100 times 1.1 to the power of 4. Now, the first term is going to be slightly different, isn't it? So what do you think the first term is going to be? Good, the first term is 100 in this one. Now what about the ratio? That's right, the ratio you can see 1.1, 1.1 squared, so it's being multiplied by 1.1 each time. And now let's finally work out the number of terms. So you can see this is to the power of 4, but because we have 100 here times 1.1 to the power of 0 essentially, that means we altogether have 5 terms. So n should equal to 5. So subbing it into the equation for the sum of the geometric series that we have here, we should have 100 times 1.1 to the power of 5 minus 1 over 1.1 minus 1. Put that into your calculator and we should get 610.51 as your answer. Now, for some of you, it may be easier to just write that out, divide by that, then multiply by 100. So whatever works for you in your calculator. Just make sure we get the right answer. Okay, looking at question 3 now, we have this series here and we want to find the sum again. But in this case, can you see we're starting off with 1000 times 1.02 to the power of 3, then to 1.02 to the power of 4, so on to the power of 6. So I want you to have a think about it now. What is our a going to be, and what do you think our r is going to be? Well, for those of you who said a is 1000, that's not right. And that's because if you have a look here, the r, everything's increasing by 1.02 each time. So that means this is actually our first term, not just 1000, but the whole thing is our first term, because r is 1.02, so it's increasing by 1.02. Can you see that? So just be careful that you don't see 1000 and just automatically assume it's a first term. We always have to consider a and r together to work out what the ratio and then what the first term will be. And now finally, let's work out the number of terms. So we have power of 6 here, and we have the power of 3 there. So from 3 to 6, there's 4 terms. Now, I know some of you get confused because we think 6 minus 3 equals to 3, but you can see here there'll be 3, 4, 5, 6, so there's 4 terms. And I find that it's easy to think about when we have small numbers, but when we're getting up to hundreds, it's easy to forget that. So what I always think is we have the last index here minus the first index, and I just always plus 1. So in this case we have 3 plus 1, so I know there's 4 terms. Yep, so we have n equals to 4, and now we've done the hard part, so we just sub it in. We have 1000 times 1.02 to the power of 3, so remember that was our first term, and then just multiplied by 1.02 to the number of terms, which we worked out to be 4 using this equation here, minus 1 over 1.02 minus 1. Putting that into your calculator, we should get 4,373.88 there. So remember, although usually we just have this number up the front as our first term, we have to always consider what the ratio is going to be. And that tells us, because the ratio was only 1.02, then that whole thing must have been our first term. So it's always good to keep your eye out for these little details. Okay, moving on here, we have this series, which is 50 times 1.5 power of 2, and then we're jumping to 50 times 1.5 to the power of 5, and here we have the power of 8, and then to the power of 11 to the power of 14. So you can see this is slightly different to what we had previously, where the first number was quite large, but the index was still increasing by 1. But you can see here that the index is increasing by 3, isn't it? So, like I was saying before, always consider A and R together when you're thinking about it. So, I think just looking at this, it jumps out at you that R is going to be 1.5 to the power of 3 because it's increasing by that. So, therefore, this must be our first term. So, we've worked out the first term is that, and that ratio must be 1.5 to the power of 3 because it's increasing by 3 each time. Now, the difficult part is working out the number of terms. So we have here 14, and it starts off with 2. So when it's small, like I said, it's easy to just count, so we can just count that it's 5 terms. But when you have thousands, it's impossible to. So what I do is the formula we used before. So we have the last term minus the first term, which just gives us 12. And you divide by 3 because each one is increasing by 3, as you see here. So that just gives us 4. But always add 1. So whatever you work out the number to be, just add 1 for that extra term at the start, which we're not counting. So in that case, this gives us 4 plus 1, so it gives us 5 terms. So we've just worked out that n should equal to 5. Okay? So I think this is good for when we have larger numbers and it's difficult to just consider in your head. Okay, let's just sub it in now. So we have our first term multiplied by the ratio, which is 1.5 to the power of 3. So that itself is a ratio, and that in brackets to the power of 5. Okay, so just be careful of that when you're putting in the calculator, that ratio here, brackets to the power of 5, okay? Minus 1, then over 1.5 to the power of 3, which was our ratio, minus 1. So putting that into the calculator, and this you may need to do in a couple of steps because it's slightly more complicated than what we had before, we should get 20694.97 as our answer. So we're just rounding everything to 2 decimal places. So you can see that A and R by now, I think we're quite good at working out what that is going to be. So what I would like you to focus on is working out how many terms there are, so the number of terms. All right, now we're going to be working with a slightly different question here. So in question 5, we want to find the smallest value of n that satisfies this inequality here. So you can see we have a greater than, so we're going to be working with the inequality. We have 10 plus 10 times 1.2 to the power of 1, 2, 3, so on, until 1.2 to the power of n minus 1. And we want to find the smallest value of n for when this series is greater than 350. So that's essentially what we're saying with this inequality. So first thing is similar to what we were doing before. We want to work out what A, R, and N is and substitute it into this equation. So once again, considering A and R together, you can see that everything's increasing by 1.2. So we know that R should be 1.2. Now that means that 10 is our first term. So A should equal to 10. And the number of terms, because essentially we have 1.2 to the power of 0 here, that adds 1 to our n minus 1 here. So there's going to be n number of terms, okay? And that's how we get this equation here, which is a, our first number, multiplied by ratio 1.2 to the power of the number of terms, which we worked out to be n, minus 1 over 1.2 minus 1, and we want to find out when that is greater than 350, so the smallest value of n. Now it's just a matter of working that out, so we can just simplify that to 0.2, and 10 divided by 0.2 is just going to give us 50. And now what we can do, divide both sides by 50. So we have 1.2 to the power of n minus 1 is greater than 7. So 1.2 to the power of n is greater than 8. Now what we need to do is use our logarithm to work that out. Now we've changed it to n is greater than log base 1.28. So all I want you to remember is the base of the index, which is 1.2, becomes the base of the log. That's quite easy to remember, isn't it? Base of index to base of log. Now we're trying to work out what n is, aren't we? So that's why we're moving n by itself over here. Yeah, so it's n equals 2 or n is greater than. And that means that 8 is left to be here. Okay, so that's how I remember it. Base of index, base of logarithm. Trying to work out what n is, so n goes over here, and 8 goes over here, because that's the only place left, essentially. Now, we can't work that out straight in our calculator, if you remember. What we need to do is change the base, and how we do that is just by changing it to log base 10, and we have 8 on top and 1.2 on bottom. And once again, the trick to remembering that is the base goes on the bottom. Yeah, so that's easy to remember. The base is always on the bottom of everything. So base goes on bottom there. That means your 8 goes on top. So you can just put log 8 divided by log 1.2 into your calculator, and you should get 11.40535, etc. as your answer. Now remember, the point of this question was we want to find the smallest value of n that made this series greater than 350. Now, usually in maths, we're used to rounding down if it's less than 11.5 and rounding up if it's greater or equal to 11.5. But it's slightly different in this case because, well, so I'll show you. Let's check n equals to 11 and then let's check n equals to 12. So when n equals to 11, putting that into our calculator, we find that it equals to 321.50, which is, it's not greater than that, is it? But when we check n equals to 12, that gives us 395.81, which is greater than that. And it makes sense when you think about it, because this is essentially the smallest number for n to be greater than that, but because we're looking for a whole number, it can't be 11 because that's smaller than that, so it's actually not going to be enough to make it bigger than. So we want the closest whole number that's going to make it bigger than that, so that's why we always round up. Yeah, so it's the same for when we're working with people or animals. In the case that we need a whole number, we're going to have to round up. So even if that was 11.1, we would still need to round up for that to be greater than 350. Does that make sense? Okay, good. So what we've done here is actually very similar to what we're going to be working with in time payments. So we've applied the equation and then we just worked out the inequality using logarithm. And remember, we always need to change the base for our logarithm to put it into the calculator. So we have 395.81. So therefore we say that the smallest n is going to be 12. Okay?